Hey guys, so this is the lesson that we did last week on angles of elevation and depression. I figured I would post it just in case some of you are absent or if you just need a refresher. So here we go. All right, so an angle of elevation and an angle of depression. Basically what these are just ways that we can use trig ratios to solve application problems. So basically most of the time they are like an angle of elevation. This first one is when someone is like on the ground looking up at something. So it's always like coming from down low looking up at something. So if you notice right here, here's the person's eye. So the angle of elevation is always formed by an imaginary horizontal line, like as if you were just going to look straight across, and then the line of sight up to the top of the object that you're trying to measure. So this is the angle of elevation. So we have a couple examples that we're going to do. The first one, this is actually real information. I actually measured all of this in my classroom, and so this is accurate measurements. So it says Mrs. Reynolds' eyes are 5.25 feet from the ground. The angle of elevation from her eyes to the ceiling is 20 degrees. If she is standing 9 feet from the wall, find the height of the ceiling. So anytime you don't have a picture, you always want to start by drawing a picture. So let's see, we need the floor. We need me. We need the ceiling. And then a few other things. So it says my eyes are 5.25 feet from the ground. So that would be this. Okay, it's not letting me right there. I'll do it on the other side. Okay, so let's go back a step. I'm going to draw my horizontal line of sight straight across, and then my line of sight to the top of what I'm measuring. So it's this angle here. That's my angle of elevation, which it says is 20 degrees. Okay. Then now I'll do my eyesight. So it says my eyesight is 5.25 feet. So that's this right here. And then it says what else? I'm standing 9 feet from the wall. If this is 9 feet, this is also 9 feet also, I should mention, because it's a rectangle. Here's our right angle. So in the end, what we're actually trying to find is this whole thing. Now notice that the triangle, the right triangle, is just right here. So what we're going to do is we're going to use this 20-degree angle, the 9 feet, and we're going to find just this part in that yellow triangle. Once we get that part, we can add in the 5.25, and that will give us the entire height of the ceiling. So just like always, we're using SOHCAHTOA. You want to take a look at the angle that you have, that's your theta, and we're going to mark the sides as opposite, adjacent, or hypotenuse. So if here's our theta, this x is opposite, this 9 feet is adjacent. Oops. So you want to think about opposite and adjacent. What is going to be used for opposite and adjacent? And that's tangent. So then we're going to set up an equation. Grab my calculator here. We're going to set up an equation. It's going to be tangent of 20 equals opposite, which is x, over adjacent, which is 9. So that's your equation. And then remember, to solve the equation, we have to get the x all by itself. So we're going to multiply both sides by 9. So now the 9s are gone. And then remember, it depends here. If you're using just a regular calculator, you can just do 9 times tangent of 20, and you end up getting 3.28, we'll call it. If you're using a phone calculator, you kind of have to do it backwards. You need to do 20 tangent and then do times 9. If you guys need me to go over that in our hangout later, we can do that. So that 3.28 is really just this part right here. So what we have to do is we have to add my eyesight to get the entire thing. So we're going to have to add 5.25. So 3.28 plus 5.25, the total height of the ceiling would be 8.53 feet. Okay, whoops, that's kind of messy. Let's rewrite that. Okay, so that's the answer to number 1. Number 2 is kind of the same idea. If you want, maybe you could pause this video and try number 2 and see if you can get it. Otherwise, I'm just going to keep going and go through it with you. Okay, so number 2 is very similar. It says Logan wants to find the height of a flagpole. He's standing 15 feet from the base of the flagpole, and his eyes are 5 feet from the ground. And then we're given that the angle of elevation is 52 degrees, and we have to find the height of the flagpole. So again, you want to draw your picture. So I have the ground, I have a flagpole, I have Logan, and then we have a couple different things. We have the invisible line of sight, if he's just going to look straight across, and then we have the line of sight up to the top of the flagpole. Okay, so now we can label a few things. His angle of elevation is 52 degrees. His eyes are 5.5 feet from the ground. Let's see, he's standing 15 feet from the base of the flagpole, so that's this. But remember that this is also 15 feet. And then here's the right angle. So then again, we're going to find this. This is going to be our x. Once we find x, we're going to add that together with the 5.5 to get the entire flight of the flagpole. Okay, so just like before, we're going to figure out which trig function we're going to use. So you're going to take a look at your angle, which is 52. Opposite the angle is the x. Adjacent would be the 15. So once again, we're using tangent. I will say a lot of the problems that we do end up using tangent. Not all of them, but many of them do. So if you feel like you're using tangent a lot, that's okay. Okay, so now we're going to set up the equation. So it's going to be tangent of 52 equals x over 15. Okay, so then to solve for x here, we need to multiply both sides by 15. So then in your calculator, you're doing 15 times tangent of 52. Again, if you're using a phone calculator, you would hit 52 tangent times 15. Okay, so you should get about 19.2 here. Remember that that's just this piece. So we're going to have to take this 5.5 and add it to the 19.2. So 19.2 plus 5.5 should give us 24.7. And so that means that the flagpole is about 24.7 feet high. Okay, so that's angle of elevation when you are down low, standing, or sometimes it's even like something just like on the ground, looking up at something. Angle of depression is the opposite. So instead of being down low, like on the ground, we are up high looking down. So notice, here's the eye. Whoops. Here's your eyesight right here. So the angle of depression is formed by this invisible horizontal line, if you were to look straight across, and then your line of sight looking down at the object. So this is the angle of depression. A very common error is that kids put angle of depression here. It's never this one. It has to be the horizontal with the line of sight looking down. So let's get rid of that. Okay. So we have a few examples. This first one is Christian. He is flying a plane at a cruising altitude of 36,000 feet. When he starts to land the plane, he descends at an angle of depression of 3 degrees. If he continues at this angle, how far does he need to travel to reach the ground? So let's say we have our little plane. Oops, switch back to this. We have our plane. You don't actually have to draw a plane, by the way. Oops, this is not working out very well. That's okay. Okay, there are my windows. All right, whatever. There's my plane. So now we have the ground. We have his cruising altitude is 36,000 feet. Okay. The angle of depression is 3 degrees. So remember that the angle of depression is formed from that horizontal. In this case, the horizontal represents like if the plane were going to keep going straight. And then in this case, the line of sight, it's not really a line of sight. I guess it's like the path of the plane. So this is the path the plane is going to take to go to the ground. Okay, so the angle of depression is up here, 3 degrees. And then it's asking us to find how far does he need to travel to reach the ground. So that would actually be this piece right here. That's our X. Okay, now notice that in this example, the angle of depression is actually not even in the triangle. Like this is the right triangle that we're going to use. But notice the 3 is not in there. So we talked about how our horizontal line of sight is parallel to the ground. So since they are parallel, if you guys remember from earlier in the year, this angle and this angle are alternate interior angles. So they'd be equal. So you can always put in that 3 degree angle or whatever the angle of depression is down in the bottom. Once you have that, then you can just solve as you normally would. So we're going to label the parts as opposite, adjacent, hypotenuse. We're going to use SOHCAHTOA to solve. So here's our angle. Notice the 36,000 feet is opposite and the X is hypotenuse. So now this one is O and H. So O and H would be sine. So it's going to be, let me switch to a different color. It's going to be sine of 3 equals opposite, which is 36,000 over X, the height. So sine of 3 equals opposite over hypotenuse. Now this one's a little bit different because the X is in the denominator. So remember what we have to do there is we multiply both sides by X because we want to get it up into the numerator. So those are gone. Over here, we're left with 36,000. Okay, and so over here, we have to, let me rewrite it. We're trying to get this X all by itself, so we have to divide both sides by sine of 3. Oh boy, I don't know why I'm saying 63. Sine of 3. So those are gone. And so now in your calculator, if you have a regular calculator anyway, you're doing 36,000 divided by sine of 3, which is a big number. It's, let's see, 683.61, and that's feet. So there's your answer. Always label feet or whatever the units are when you're working with something like this. Now, if you're doing this, if you're doing this on a phone calculator, let me just double check. One sec. I'm just going to bring up my phone calculator just to verify how you would put it in. So you'd put in 36,000 divided by 3 sine equals. Yeah, so again, you would do 36,000 divided by 3 sine equals, and that should give you that answer. Okay, so that's example 3, and the last example is about Tommy bird watching in a tree. I don't know why he's bird watching in a tree, but he is. Okay, so Tommy's bird watching in a tree when he spots a blue jay on the ground. The angle of depression from Tommy to the bird is 35 degrees. If Tommy is 15 feet high in the tree, how far is the bird from the base of the tree? So we need a picture. Here's the ground. Here's our tree. Oh, I didn't want it to be a circle. That's okay. There's our tree. Let's see. Here's our little bird. Little blob. It's hard to make an actual picture here. Okay, there's the bird. Here's Tommy in the tree. And let's draw the parts. So angle of depression is formed by an invisible horizontal line, as if Tommy was going to look straight across. Then Tommy's line of sight down to the bird. Okay, so the Tommy is 15 feet high in the tree, so that's this part here. So let's label that. Okay, here's our right angle. The angle of depression is 35 degrees. We want to know how far is the bird from the base of the tree. So if this is the base of the tree, oops, no. If this is the base of the tree and there's the bird, like this is what you're trying to find. Okay, remember that an angle of depression is alternate interior to this angle down here, which is actually also the angle of elevation from the bird to Tommy. So those are always the same. Okay, now that we have that, we can solve. So you want to label the parts as opposite, adjacent, or hypotenuse. So let's see, I'm going to use this color. So this would be opposite the 35. This would be adjacent to the 35. So opposite and adjacent. Think about SOHCAHTOA would be tangent. So it's going to be tangent of 35 equals 15, which is opposite, over x, which is adjacent. Again, this is one where x is in the denominator, so we have to solve for x. To get x up into the numerator, we're going to multiply both sides by x. So that's gone, so we have 15 over there. Over here, we have x times tangent of 35. Okay, so now to solve for x, we need to move that tangent of 35 to the other side. So I'm going to divide by tangent of 35. Okay, those are gone. And we have x is approximately. So now we're doing 15 divided by tangent of 25. Oops, 35. If I said 25, sorry, it's 35. So you should get about 21.42. And that's feet. Again, if you're doing this on a phone calculator, you would do 15 divided by 35 tangent equals. So 15 divided by 35 tangent equals. That's how you would do it on a phone calculator. Okay, so that's angle of elevation and angle of depression. Be sure to send me an email if you still have questions about this, and I will get back to you as soon as I can. All right, talk to you guys later.